Hey, what's up guys? My name is Saurav and this is my YouTube channel Data Science Novice. So if you are new to this channel, please do like and subscribe. Your efforts are massively appreciated. So I'm back with another missing values technique. So if you don't know, this is a lecture series on data pre-processing techniques where we are going to learn how to prepare data for machine learning algorithms. In this series, we are going to understand techniques like creating missing values, variable encoding, or outlier detections. Full information of this course can be found in the first video of the playlist. So if you are new here, I would suggest you to watch that video where I have explained the roadmap for this course. So today we have yet another technique called ant-tail imputation. So first we are going to understand this technique. Then we will see which kind of data or variable we can use them. And then finally we see the advantages and disadvantages of this technique. So in this technique, we replace the missing values with either of the extreme values of the distribution. Now, if we try to relate with the previous technique, there we were replacing the missing values with the center value of the data. And here we are finding the extreme value of the data and then replacing it with the missing values. And the idea is that we don't know much about missing values. So here we are trying to make our best guess. So either the missing values is going to be in the center or it is going to be on extreme values. We don't know. We have to explore this thing because it's a gray area. And that's the whole point of these kind of different techniques. Next thing is that this technique can only be used for numerical data. We cannot use it with the categorical data. One thing that we have to keep in mind while calculating the ant-tail values, we have to split the data in train and test in order to avoid the data leakage and to test whether this technique will be useful during deployment process or not. So why this is the case? Just try to relate it with model buildings. Before building the model, we divide the data set into two parts, that is training and test. So we train the data on the training set and evaluate the model performance on the test data in order to see if the model is performing same as on training data. And if we don't do this, we will never get to know the actual performance of the model. And after model deployment, we may see decrease or increase in the performance. Just try to relate with how you study for an exam. Like first we read all the materials that we have, then we test our knowledge by creating the same environment as the actual exam, like giving mock test. And this helps us improving our performance. Now try to bring the same understanding here. So if we don't split the data, we will never get to know that how this technique or any other technique is affecting the model performance, because then we will be applying the technique in the whole data set. So that's why it's preferable to split the data before applying any sorts of pre-processing technique. Next thing is that in this technique, ant-tail calculation depends upon the kind of data distribution followed by the variable. That is, how to calculate the ant-tails of the distribution is entirely dependent upon the data distribution. And from the previous video, we know that what kind of distribution is followed by the continuous variable. And if you guessed it right, yes, I'm talking about normal distribution and skewed normal distribution. And if you don't know about it, I will walk you through it. So what is normal distribution? Although we have talked about it in the previous technique, so I will just go through it quickly. So normal distribution is sometimes called as bell-shaped curve. And obviously the name comes from the fact that it looks like bell. It is symmetric about the mean and it is unimodal in nature, that is, it has single mode and the mean median mode are equal. Then there is a constant proportion of population lying under the curve between the mean and a specific number of standard deviation. It means that the population one standard deviation below the mean is equals to the population above one standard deviation. And in many books, you will see something like mean plus minus one standard deviation contains 68.6% of the population, and so on and so forth, which we can see in this picture as well. So that's a quick intro to the normal distribution, and obviously there are many things that I haven't talked about it because it is not in the scope of this course. So maybe I'll create a course on statistics in future and there we will deep dive into the normal distribution. Now coming to the part how to calculate the extreme values. So to calculate the extreme values or upper limit or lower limit, we use this formula which is basically gives the idea about population. So the value at mean plus 3 standard deviation will be the upper limit for the data and the lower limit will be the mean minus 3 standard deviation. So here we are going to get two values, and which one to use, that is whether we use lower bound or upper bound, that we have to explore ourselves. And one thing you will notice that if we set 3 to 0, we get the mean of the data. So in that case, we are replacing the missing value with the mean, which again solidify the point I talked earlier. That is, here we are just trying to find a value as per the distribution that can be a representative of missing values in the data. It could be center, it could be extreme value, and there is no hard and fast rule that this technique is good for that kind of data or that technique is good for this kind of data. This is a gray area and we have to explore ourselves that which technique works best. That's why knowledge of multiple technique is handy and it makes life easy. Next, we have the case of skewed normal distribution and how we calculate the ant-tail values. So again, let's quickly review what is skewed normal distribution. So these distribution look similar to normal distribution, but they are asymmetric in nature. That is, the two halves are not mirror image of each other, and in picture we can see that. In skewed normal distribution, we have two kinds of distribution, that is negatively and positively skewed distribution. And obviously here the mean median modes are not equal and the skewness in the data is due to the presence of extreme values or outliers. Now talking about how to calculate the ant-tail values here. So first we have to calculate the IQR, that is interquartile ranges. So IQR is nothing, just we are trying to find out where is the middle 50% of data is. So in simple word, it tells us where is 50% of data is concentrated in skewed distribution. And to calculate it, we simply subtract 25th quartile from 75th quartile after arranging the data into ascending or descending order. And we don't have to worry about all these calculations. NumPy has dedicated function for this. So once we have IQR, we simply use the formula written here. For the upper limit, we do 75th quartile plus IQR into 1.5. And for lower limit, we simply do 25th quartile minus 1.5 into IQR. And in the practical section, we will build two functions, one for normal distribution and one for the skewed normal distribution. So now let's talk about advantages and disadvantages of this technique. So first we are going to talk about the advantages. So this technique is easy to implement and can be integrated in the production environment. This technique does not introduce any kind of outliers in the data, and this technique works better with tree-based algorithms like decision tree, random forest, etc. etc. Now talking about the disadvantages of this technique distorts the original distribution, hence statistical properties changes with other variable. This technique changes the normality of the data, that is why we avoid using this technique for linear models like linear regression. It does not capture the dynamic nature of the data, that is, if the extreme values changes in future for the distribution, we will have to re-evaluate the model and we will have to make some changes. So that's all for this video. And in the next video, we will see the Python implementation of this technique. And if you are new to the channel, please do like and subscribe and press the bell icon for the future updates. So see you in the next video. Till then, bye, stay safe and wear a mask.